Now let us begin with the topic of continuity of a function. We all are already familiar with the process of finding out the limit of a function, right? Now based on that only we go one step ahead and define what is called as continuity of a function. So here goes the simple definition of it. A function f of x is said to be continuous at x equal to a if and only if the limit of function as x tends to a is equal to the value of the function at x equal to a. So in simple words, a function is said to be continuous at some point x equal to a, provided the limiting value of the function as x tends to a is equal to the actual value of the function at x equal to a. Right? So that is the definition of the continuity. Now if we just look closer, that is when we say that limit of a function as x tends to a, it automatically means that the left hand limit and right hand limit of that function must exist as well as they must be equal to each other. Only then we will say that the limit of a function in general exists. Alright. So therefore splitting the definition of the continuity, we can write in more detail as a function f of x is said to be continuous if its left hand limit is equal to its right hand limit as x tends to a in both cases, and this common value in turn has to be equal to the value of the function at x equal to a. So this is the way to define the continuity, and whenever we are given the sums based on continuity, we check whether this particular condition is satisfied or not, right? So let's go ahead and see few more concepts related with this. Now there are a couple of notes here, that is, first is all the standard functions, that is algebraic, trigonometric, logarithmic, exponential and modulus. See, these functions are always continuous in their respective domains. Okay, so there is no need to every time check the limit and the actual value of the function at a given point to test the continuity of these functions. We can take it as a standard result and use it in the examples. Now secondly, addition, subtraction, multiplication and division of two continuous functions is also a continuous function. Alright, so that is a very simple rule that we have to remember. And of course for the case of division, the denominator function should not be 0, otherwise we won't be allowed to divide. Right. Now moving on, there is an informal way of testing the continuity of a function over its domain. That is, if we can draw the graph of that function without lifting the pen anywhere, then the function will be nothing but continuous in its domain. So that's the graphical interpretation of continuity of a function. That is, let's consider some simple function. Say when I say that f of x is equal to x square. Alright. Now we know that how the graph of this particular function looks like. That is, it will be a parabola opening upwards. So when I start drawing the graph, you can see that I can draw the entire graph without lifting the pen anywhere. So therefore we say that this function is a continuous function. Alright. Now let's take another function. Suppose you consider the signum function. If you remember, the signum function is such that if we consider x to be positive, then the value of the signum function is +1. If it is negative, then it is -1. Okay, and if it is 0, then the value of the signum function is 0. So now if you see the graph of the function shown in yellow color here, whether we start from left or whether we start from right for drawing the graph, at the value 0 we have to lift the pen. Therefore we cannot draw the entire graph throughout the domain without lifting the pen. So therefore we say that this function is not continuous at point 0. So this is one more important thing to remember, that is the continuity is basically defined at a particular point, and therefore if we were talking about the continuity in the entire domain, then basically we are talking about the continuity at each and every point in the domain. Alright, so therefore the signum function, as we can see, is not continuous at x equal to 0, but yes, it is continuous at any other value of the x. So if we consider, say, x equal to 4, then you can draw the graph of the function in the neighborhood of 4, without lifting the pen. So therefore at that point it is continuous, but at x equal to 0 it is not continuous.